Okay, today we're going to talk about using dot plots to compare populations. So, a test prep company gives its students a pre-test before the course and a post-test after the course is completed. The test prep company picks a random sample of 10 students from each testing session. Okay, so what we could do is order this from least to greatest and then plot it on the number line. We're just going to go through, and every time we see the number,
Ángel Perales, please report to the front office. Ángel Perales to the front office.
we are going to make a dot. So on the first one, pre-test, 520, we are going to make a dot. 510, make a dot. 550, make a dot. 580, make a dot. 600, make a dot. 480, make a dot. 480, make a dot. 460, make a dot. 460, make a dot. And then lastly, 640, make a dot. So for the pre-test scores, our dot plot should look like this. Now we're going to make a dot plot for the sample of the post-test scores. So the post-test scores, we have 510. Make a dot. 480, make a dot. 510, make a dot. 610, make a dot. 590, make a dot. 670, make a dot. 550, make a dot. 560, make a dot. 600 and 610. So our dot plot should look like this for the post-test. Now it says compare the dot plots. The dot plots have a similar center and a similar spread. Well, remember our vocabulary words. Center is a key word for median. So write down median above that. And spread is a key word for range. All right, so if I was going to find the median, I have to cross off till I get to the middle. So let's do that for the pre-test. 460, 640. 460, 600. 480, 580. 480, 550. And we have 2 in the middle, so we are going to circle the 2 in the middle. When we have two numbers in the middle, we have to add them up and divide by 2. So we are going to add up 510 plus 520. When we add this up, we get 1030. So then we do 1030 divided by 2. We go in there 5 times. We go in there 1 time. And we go in there 5 times. So for the median for the pre-test, we have 515. So now we're going to do the median for the post-test. So when we cross off, till we get to the middle, now we have these 2 in the middle. So when we do these 2 in the middle, we're going to have to add them up. So we are going to add up 560 plus 590. So we add up 560, 590. We are going to get 1,150. 1,150 divided by 2 goes in there 5 times. 7 times and 5 times. So the median for the post-test is 575. All right, so we look at 515 and 575. I wouldn't say that those are similar. So now we need to look at the spread, the range. In order to find the spread or the range, you have to take the greatest number minus the smallest number. The greatest number is 640. The smallest number is 460. So when I subtract this, I got to borrow. We're going to get 180 for the range. And then now we're going to find the range of the post-test scores. So the range of the post-test scores, we have the highest number. The highest number is 670. The smallest number is 480. When I subtract, I'm going to have to borrow. So 17 minus 8 will get me 9. 190. All right, so if we're trying to see which one was more similar, I wouldn't say 515 and 575 are similar, but 180 and 190 are more similar. So we're going to say the spread. All right, and then it says, but the post-test values were shifted. If you look, most of the data for the pre-test was to the left, and most of the post-test data had shifted to the right. The conclusion that we can draw about this is that when the students first took the pre-test, their scores were not that good. Then they studied. After studying, and they learned from their mistakes that their scores improved. So what can we infer about the populations by comparing the dot plot for the samples? So we could say the test prep helped improve the scores. The test prep helped improve the scores. The reason why they didn't do so good with the pre-test, but once they got the test prep, their scores went up. All right, let's go down to the bottom part, using box plots to compare populations. So on the bottom, we have the girls and the boys. A survey of 7th graders asked girls and boys how many baseball caps they wore. So the first thing we need to do is arrange the girls from least to greatest and the boys from least to greatest. So when we do this, we're going to take the smallest number, which was 3. Then we got the next number, which is 4. Then we have 5. We have 6. We have 2 7s. We have 3 8s. And lastly, we have an 18. Okay, so that's for the girls. Now we're going to do the boys. So with the boys, the smallest number was 7. The next number was 9. And then followed by 10. We had 2 10s. 12. Then 15. And 2 18s. All right, so when we are plotting this, we need to first identify the least number. The least number for the girls was 3. So 1, 2, 3. Make a dot. The greatest number was 18, 16, 17, 18. All right, then we could do the same thing for the boys. The least number is 7, 6, 7. The greatest number is 18, 16, 17, 18. Now we got to find the median. So the median, you cross off till you get to the middle. We have 2 numbers in the middle, but the numbers are the same, so we don't have to add them up and divide by 2. We can just put 7. All right, then we have to do the lower quartile. And remember that the median for the lower quartile is the 2 numbers in the middle. We are going to involve this 7 in the lower quartile. So we're going to split the data in half from here. We're going to cross off the 7, the 3, the 4, the 6. The 5 is the lower quartile. Then this is the upper half of the data. We are going to cross off 7, 18. I believe that was a 8. So cross off the 8, circle the 8. So the 8 is the upper quartile. So 5, 6, 7, 8. When we do this, we are going to create our box around the lower and upper quartile. Then we are going to connect our greatest value and our least value. All right, now we got to do the same thing for the boys. For the boys, we cross off till we get to the middle. When we get to the middle, we're going to have 2 numbers in the middle. We don't have to add them up and divide by 2 because they're actually the same number. Now, in this case, when you have an even amount of data points, this number goes in with the lower value and this number goes in with the higher value. So you cross off till you get to the middle. 7, 10, 9, 9. Circle the 9. The 9 is the lower quartile. Then you do the same thing with the upper numbers. This is a part of the upper numbers. 10, 18, 12, 18. Circle the one in the middle. The one in the middle is 15. So you make a box around the lower and the upper quartiles, 9 and 15. Make a line for the median at 10. Connect the greatest value and the least value. Okay, so it says compare the box plot. The plot for boys has a blank range, but a blank interquartile range. So let's take a look at range. To find range, you have to do the biggest minus the smallest. On the girls, the biggest number is 18. And the smallest number is 3. 18 minus 3 is 15. On the boys, the biggest number is 18. The smallest is 7. So 18 minus 7 is 11. So it says the plot for boys has a blank range. Well, the boys, 11 is less than 15. So they have a lesser range. Now, but a blank interquartile range. If you remember, interquartile range is the upper quartile minus the lower quartile. So the upper quartile is 8. 8 minus 5 is 3. Then you have this upper quartile, which is 15, minus this lower quartile, which is 9. So 15 minus 9 is 6. So the boys have a larger interquartile range compared to the girls. Their interquartile range is 6, the girls is 3. If you notice, their rectangle is also bigger than the girls' rectangle. It says the middle 50% of caps was less spread out for the girls. So I just pointed that out. Their rectangle is smaller than the boys' rectangle. So what can you infer about the populations by comparing the box plots for the samples? Well, what we can infer is that if you notice, the boys are more shifted to the right than the girls. So what we can infer is that boys wear more baseball caps than girls. Boys wear more baseball caps than girls. All right, flip it to the back side. Okay, on the back side, you need to calculate the mean. Mean is a key word for average. So to find the average, you will have to add them all up and divide by how many there are. So you need to add up all of the data points.